How did volcano hellfire do this to our planet? 700 million years ago, planet Earth went from this to this. Nobody knows exactly why, but new research from Harvard may hold the answer. Scientists suggest that sulfate aerosols, resulting from years of continual volcanic activity, may have led to the Earth becoming relatively frozen, or what's known as a Snowball Earth. The research postulates that 10 years of eruptions from volcanoes, spanning 2,000 miles across an equatorial landmass, could have plied the stratosphere with just the right amount of sulfur dioxide to radically alter Earth's climate. Sulfur dioxide is very effective at reflecting solar radiation when it gets to the higher levels of the atmosphere. Once there, it can remain for up to a year. This, plus the location of the volcanoes along the equator, may have created an atmospheric barrier against the sun. The cooler climate would have then created more ice, which in turn would reflect more sunlight. The research theorizes this process continued until the ice reached present-day California's latitude. There, the freezing Earth would have become irreversible, and ice would have eventually covered all of Earth. Or in other words, the ice both literally and figuratively snowballed the planet. Say no to safe spaces on YouTube. Support TomoNews at patreon.com/TomoNews. Strap in, Tomo sapiens. We're gonna school you more on the wonders of the wee blue planet we all call home. Satellites detect serpentine iron jet stream at Earth's core. Scientists have discovered something big, thick, and as hot as the sun that's quickly coiling around the center of the Earth. European Space Agency satellites have detected a large jet stream of liquid iron flowing beneath Earth's surface at a quickening pace. The stream is moving westward beneath Canada and Russia at a pace of 30 miles per year. Lead researcher Phil Livermore explained the discovery as an accelerating band of molten iron circling the North Pole like the jet stream in the atmosphere. This molten jet stream might be caused by buoyant forces in the Earth's core, or variations in the magnetic field within the core. And no, before you ask, it's not Marijuana Man's fabled trouser snake. We know, we already checked. How a solar EMP could plunge the Earth into Stone Age darkness. So-called space weather events can be traced to coronal mass ejections, or huge bursts of gas most often associated with solar flares. These solar storms send huge quantities of electromagnetic radiation towards the Earth. That's not good for power grids. A solar electromagnetic pulse, or EMP, could take entire power grids offline, plunging the world into darkness. In 1859, one of the biggest solar storms ever recorded, the Carrington event, hit the Earth. It disrupted telegraph systems and shocked telegraph operators. A much smaller solar storm in 1989 caused the collapse of Hydro-Quebec's electricity transmission system, resulting in a 9-hour power outage. In 2012, scientists observed a solar storm believed to be as big as the Carrington event. Fortunately, it missed Earth by about 9 days. The U.S. is preparing for the next large solar EMP. It's studying potential effects of space weather on power grids, backing research to better model and predict space weather, and calling for greater cooperation among scientists and agencies at the international level. Could a new volcano be forming in New Zealand? Scientists say a buildup of magma found near a small town in New Zealand is responsible for thousands of small earthquakes in the area. The presence of the magma could also mean that a new volcano will form above the Earth's surface. A huge magma buildup has been discovered on New Zealand's North Island, near the town of Matata, in the Topal volcanic zone. Scientists using GPS data and satellite images say the magma has caused a 400 square kilometer area of land to rise 40 centimeters since 1950. The magma probably also triggered thousands of small earthquakes in recent years that were previously attributed to tectonic shifts. The researchers claim there is enough magma located 10 kilometers beneath the town to fill 80,000 Olympic-sized swimming pools. The magma could cause a volcano to form, but the process would take hundreds or thousands of years. It is also possible that over time, the magma may cool and solidify underneath the Earth. New Zealand is home to several active volcanoes, but there have been none near Matata for at least 400,000 years. So maybe it's time for Matata's 650 residents to start considering a move. say no to safe spaces on YouTube. Support TomoNews at patreon.com/TomoNews.
Giant magma reservoir found beneath Yellowstone supervolcano. A giant magma reservoir beneath the Yellowstone supervolcano has been discovered and mapped for the first time by scientists from the University of Utah. Scientists discovered a giant reservoir of magma beneath the Yellowstone supervolcano in Yellowstone National Park in Wyoming. Seismic waves sent out by earthquakes travel through hotter, molten material more slowly. Scientists used seismometers to measure the time these seismic waves took to pass through the molten material to calculate how much of it there is underground. The results show that the magma reservoir lies 12 to 28 miles beneath the supervolcano and has a volume of 11,000 cubic miles. The reservoir contains 98% solid rock and only 2% molten rock. The Yellowstone supervolcano has erupted 3 times in the last 2 million years, with its most recent eruption 640,000 years ago.
Middle East and North Africa, soon to become uninhabitable. A group of researchers believes temperatures in the Middle East and North Africa will rise dramatically over the course of the 21st century. The research suggests even if Earth's average temperature increases by 2 degrees Celsius, summer temperatures in the Middle East and North Africa will increase more than twice that. The temperature could rise to 46 degrees Celsius during daytime by mid-century, and it could be as high as 50 degrees Celsius at the end of the century. Also, heat waves could occur 10 times more often than now. The hottest period lasted for about 16 days on average between 1986 and 2005. However, these areas will experience 80 days of extreme heat per year by mid-century, and up to 118 days by the end of the century. The increasing air pollution caused by desert dust storms could make the environmental conditions intolerable, forcing people to migrate. New study reveals cause of glacier melt in Greenland. During the summer of 2015, Greenland experienced its highest rate of glacier melt ever recorded. A study shows the record-high melt is linked to the effects of a phenomenon known as Arctic amplification. Arctic amplification refers to the faster warming of the Arctic compared to the rest of the northern hemisphere as sea ice disappears. It is fueled by a feedback loop. Rising global temperatures are melting Arctic sea ice, leaving dark open water that absorbs more solar radiation, further warming the Arctic. According to the study, the atmosphere and the oceans combined are contributing to the melting of vast ice sheets off the coast of northern Greenland. The effects of Arctic amplification are unknown, but scientists believe it can change the Arctic jet stream flow, which circles the northern latitudes. Jet streams are narrow bands of strong winds in the upper atmosphere that follow the boundaries of hot and cold air. In the Arctic's case, frigid polar air is separated from warmer air in the south. A slowdown in the jet stream would cause wilder swings and allow it to bend farther north than usual, creating a high-pressure system called a cutoff high. The cutoff high draws in warm air from lower latitudes, leading to greater ice melt conditions. The study found that during the warmest summer in Greenland, the jet stream reached latitudes never before recorded during that time of year. The Arctic amplification is now cited as the cause for the melting of Greenland's ice sheet, which is the Earth's second largest after Antarctica. The ice sheet holds enough ice that if it were to melt entirely, it would raise the average global sea level by about 7 meters and lead to ocean warming worldwide. Ocean acidification has already led to a decline in coral reef growth. It's a well-known fact in the science community that coral reef growth worldwide has been slowing down for years, but no one has been sure why. A study published Wednesday in Nature measured the growth of coral reefs in pre-industrial conditions, when carbon dioxide levels in the atmosphere were much lower. Results of the study directly points to a single culprit behind slowing coral growth: ocean acidification. 40% of the carbon dioxide in our Earth's atmosphere is absorbed by oceans. CO2 forms carbonic acid in water and free hydrogen ions, leading to higher ocean acidity. Over the past 2 centuries, the ocean's average pH has dropped from 8.2 to 8.1. Since the pH scale is logarithmic, a jump from pH 8.2 to pH 8.1 is a significant 26% increase in acidity. Coral uses carbonate ions to build their skeletons, but hydrogen ions released after the formation of carbonic acid binds to carbonate, forming bicarbonate. This leads to a deficit of carbonate ions in oceans. A recent study in Australia's Great Barrier Reef confirmed the effects of ocean acidification. Scientists pumped sodium hydroxide, a base, into the water and showed that coral grew faster in less acidic water. Protecting coral reefs from acidification is crucial. They're home to 800 coral species and 4,000 species of fish, which is more than 25% of the world's fish species. Until Wednesday's study, it wasn't clear what exactly causes the slowdown in coral reef growth worldwide, because various factors like warming oceans and pollution are known to impact coral reefs. But now it's pretty clear what could eliminate some of this slowdown in coral growth: reducing carbon emissions in our Earth's atmosphere.